So as you're
All right,
aware,
wait, hold on. We need to figure out first how many existential crises are we going to go through in this episode.
so this
I
is
think
exactly the problem.
okay.
That's exactly what I was going to comment on. Because as you're aware, throughout this series, we've come in contact with quite a few difficult scenarios to wrap our heads around when it comes to the planets, right? I myself was not prepared for the type of existential crisis I made for myself while researching this. So I just want to say, with the utmost sincerity, don't panic. Okay, there's a lot of information. I'm just gonna preface this entire. Don't panic. Okay.
Hello, everyone, and welcome to the show. I'm Blair.
And I'm Kirsten, and we are mediocre content. And we are literally halfway through September already, and I might throw up.
Scorched by the sun. It's
not in
time
September
to move into fall.
It
Get
is.
your Gilmore Girls and your pumpkin spice lattes. It's time.
This is kind of appropriate. We're kind of ending the solar, well, not really ending. We're just kind of, this is where we're ending for now, but also with
Kirsten
the end
said,
of
I got
summer.
more for you guys at
Look,
some point in the future.
At some point, we're going to have to talk galaxies, but I feel like we've had enough for now, and that's fine. But now that we're talking about the sun, and it's also the end of summer, it kind of vibes, you know? It's smart placement. Not on purpose, but it's okay.
Yeah. It's mediocrely coincidental.
It is. It's not like we would have any forethought for that in the slightest.
Correct. No, but it's true. I got my first pumpkin cream cold brew the other day, and I have never been more happy in my life. The serotonin was running through my veins. Also the caffeine, because I'm, as you guys know, I am not a caffeinated girly most of the time, but I made an exception for the pumpkin cream cold brew, and I was lit. Let me tell you.
That's a different kind of experience, isn't it?
I was like walking through Target, like, I need this and I need this, and we're gonna like run 3 miles later, and we're gonna do all these other things.
Just
a great time.
Setting the mood, honestly.
It's a great day. Yeah. It was beautiful.
Good. I, on the other hand, am on my second cup of coffee, which is unusual for me. I don't usually drink more than one, but I was just in the mood today. So I feel like I needed it. Yeah.
Yeah. A little treat, a little something. I got you.
But there's a lot of content in this one. So to be honest, we might want to, you would not think so, but there's quite a bit that I needed to include here. So we might want to disclaim, honestly.
Yeah, sure. All right. So we are not experts on anything. If you listen to advice from us, you will get burned
by the sun.
So don't trust us with any, like, don't use us for your research papers at home.
Oh no.
Because people casually do those apparently. And don't, just get your own research somewhere else. We would love to spark joy and inspire you to research a topic, but don't take any of this information super seriously. Take it with a grain of salt, because we do our best here at Mediocre Content, but I
mean, we're using NASA,
right? So it's a pretty reliable source, I would say.
Yeah, but still,
however, it's not, we're a two-woman research team. That's it.
There's very few sample size.
Right. So our perspective is not always like, spot on, / our research abilities are limited.
Fair enough. But you got the good news this week.
Yes, I do.
So fun.
Yes, indeed. So the first good news is about a New Jersey diner couple. And when I say diner couple, I mean they literally spend a lot of their free time in diners.
Oh, that's awesome.
John and Carrie Ricklin have been married for 39 years, and their goal is to visit every diner in New Jersey.
Oh, wow.
They started this in 2015. Quote, our quest is to eat at every diner in the state of New Jersey. I know. I love how it's
I like
a quest.
This quest.
We have more diners in New Jersey than any other state.
Oh.
Yes. End
Really?
quote. New Jersey is known for its extensive collection of diners, which I didn't know until I read this article, but I am very pleased with that.
I'm close enough. We could do that.
Yeah, we should do that. We should podcast from a diner. Diner podcast.
For real.
Quote, we just thought that it would be cool to drive around the state and sample and eat at each diner. It's turning out to be a bigger quest than we probably originally anticipated.
Look, if you're telling me that New Jersey is known for their extensive diner collection, and then you're like, oh, it's bigger than I thought. It's an entire state's worth, John.
Right. That's right, John.
That's amazing, but also huge.
So the question was posed, why diners? And Carrie, the wife in this couple, said, you got to eat, which, I mean, she has a fair point.
She's not wrong.
She's not wrong. Although the explanation is straightforward, John explains the backstory in a bit more detail. It all started with their very first diner and a quick snapshot. We were ordering and Carrie just said, let me take your picture. I was holding the menu and she just snapped a picture of me holding the menu. Half jokingly, I said it would be really cool if we could take this exact same picture at every diner in the state of New Jersey. At the time, having no idea how many there were.
That's adorable.
As a state with many, many diners, eating at every single one of them has been quite the undertaking.
Mm-hmm.
And it could never be over easy. Get it? But slowly but surely, John and Carrie have been meeting the challenge. John says, I keep a database and I try to keep up with it as best I can. Right now, he has about total 415 diners. And right now, they're at 212. So they're about half.
Nice. Are they writing reviews as well along the way to be like, oh, this one was fantastic, or oh, this one was butts?
Their Instagram account, NJ Diner Journey,
boasts
many posts about John posing with a menu, and many of the spots he and Carrie have visited. There will be one, though, that feature. There will be one that features Al Roker is the one who like interviewed them.
Yeah.
Thing, who asks to pose with him for this diner photo. So they document where they're going and stuff. I don't know if they say like if they like it or not.
That would be cool if they did. That way, I mean, if you're gonna do it, you might as well be thorough so that people know which ones to hit up.
It's true.
That's so cute, though.
Yeah, very cute. John owns a dry cleaning pickup and delivery service and Carrie's a nurse.
Aw, cute.
I know. Okay, second good news is about a weird giraffe.
What?
Yes.
Okay.
We have all heard of melanistic leopards, albino pythons, and great white whales. But how about this little princess born at the zoo in Tennessee? You'd have to go back to the 1970s to find the last recorded instance of a giraffe being born without spots.
Oh my God. That's so
born
cute.
On July 31. She's already as tall as the average NBA player.
Holy crap.
Totally healthy and content under the watchful eyes of her mother. Bright's Zoo has decided to give the young one a name in Swahili, Kipiki. Wait a minute. There's like 5 different names.
Yeah, it sounds like the names all mean
the same thing.
Like beautiful, unique.
Okay.
Because she doesn't have the spots, but it sounds like it's in like 5 different languages, which is insane.
Oh, cool. Okay.
Yeah.
So Kipiki, Shakiri, Jamila, and Firali?
Yeah, I'm not sure. Yeah, that's how I would say it. Yeah.
All of which mean either beautiful or unique. are being considered. Oh, so they haven't decided.
That would be
That's
cool if they
why.
just had it in
Okay.
5 different languages, though.
Yeah.
Adorable.
I swear I read this article before I put it on here.
Mediocre content.
Giraffe spots are critical for several reasons, and for the young female will give an opportunity for scientists to study the animal's physiology without them. For starters, they make for superb camouflage, even despite the animal's unmistakable long neck. The pattern is personal to each giraffe, such as a fingerprint to each human, and it's thought they inherit most of them from their maternal lineage. Underneath their skin, they contain a system of blood vessels that allow them to release body heat through the center of each spot. Wow, I didn't know that. Providing much needed thermoregulation in the heat of the African day.
This makes sense.
So either she'll be really good at regulating her heat because she has one giant spot, or she won't be very good at regulating her heat.
Could be either.
The international coverage of our patternless baby giraffe has created a much needed spotlight on giraffe conservation. It is a good thing she was born in captivity, as the lack of spots would probably compromise her ability to hide from predators. Definitely.
Minor thing. It's like
natural selection.
Damn. You're right, though.
Anyway.
That's so cute.
Yeah.
Honestly, we're going to talk about another sunspot, but this one's a little bit bigger than that one even.
Oh, yes.
How was that segue? Was that pretty good?
That was a beautiful segue. I applaud you.
Thank you. I love the giraffe story. It's so stinking cute.
It is cute.
And it has given us a bit of a lighthearted start, because I'm not going to lie to you. Okay. So as you're aware,
all right, wait, hold on. We need to figure out first, how many existential crises are we going to go through in this episode?
So this is exactly the problem.
Okay.
That's exactly what I was going to comment on, because as you're aware, throughout this series, we've come in contact with quite a few difficult scenarios to wrap our heads around when it comes to the planets, right? I myself was not prepared for the type of existential crisis I made for myself while researching this. So I just want to say, with the utmost sincerity, don't panic. Okay, there's a lot of information. I'm just gonna preface this entire don't panic. Okay, there's a lot of information because the sun is old. Okay.
Yes.
The sun is very old. There's a lot of predictions and information about how the sun lives in the solar system, and how it's like born, created, because after it's a star, and there's a lot of information around that. So there's a lot of things that are going to seem mentally very overwhelming, and I was not even prepared for that. So just to prepare you all for this, you may walk away with a small existential crisis, but just kind of dismiss it immediately, because it's not even worth your time, to be honest.
Okay. Right.
So we'll start there. So prepare yourself.
Got it.
For starters, as I said, unlike
7 years ago. Sorry. Okay.
Fortnights ago. So the sun is actually a star. It is not a planet. Unlike all the other pieces we've been talking about thus far, for the most part, except for the moon, obviously. It's a star, specifically a yellow dwarf star. And from our vantage point on Earth, the sun may appear like an unchanging source of light and heat in the sky. However, the sun is actually quite dynamic and constantly changing and sending out even energy into space. And the science of studying the sun and its influence throughout the solar system is called heliophysics. So if you want a word to describe it, it does have its own. And you might even be able to, if you're interested in heliophysics, you could study that specifically and be a sun expert, basically. Well, a star expert. I don't know. The name origin, it's been called many names. The Latin word for sun is sol, which is the main adjective for all things sun related. So solar, for example.
Yep.
Helios, the sun god in ancient Greek mythology, lends his name to many sun-related terms as well. Again, heliosphere, heliophysics, helioseismology. There's a lot.
Helioseismology. That's not one you hear every day.
It is not, but it rolls right off the tongue, doesn't it?
It really does.
I like it. And as we discussed, it's very old. It's about 4.5 billion years old as it stands today. So it's got a lot of history, is the reason.
It's weird to think that some people on this earth have more money than the sun is old.
You know, when you say it like that, yeah.
Just putting that out there for everybody.
And now I want to vomit for a different reason. No, I'm just kidding.
That's right.
So in terms of information, it's basically like we're going to cover similar things that we have for the planets. Like we'll talk about the structure, its orbit, its radius, those kinds of things. But something that we haven't talked about is something called distance from the center. And of course, every planet technically does have a center point and then a distance to it. But this is just a little bit different because the sun genuinely doesn't really have a surface, which we've talked about planets. Like, it's just, we'll get into it. Doesn't matter. The distance from the center is about 26,000 light years. And if you need an idea of what that is, a light year is the distance it takes light to travel in 1 year, which equals about 6 trillion miles or 9.5 trillion kilometers. And that's just one light year. The distance to the center of the sun is 26,000 of those. Mathematically difficult.
That's too far.
It is very far, in fact.
Yeah.
It's more than a Sunday drive. The length of one day is 25 Earth days at the equator. However, it's 36 Earth days at its poles, which is extremely trippy mentally as well.
Yeah.
The sun is considered the largest object in our solar system with a diameter of about 865,000 miles or 1.4 million kilometers. And even though the sun is the center of our specific solar system and is essentially our survival tool, other than the water that we have on the planet, it's only an average star in terms of total size. Stars up to 100 times larger have been found outside of our system, and many solar systems even have more than one. So basically, with all of that said, it's not the biggest. Still, it would take about 1.3 million Earths to fill the sun's volume in general. So it's not the biggest, but it's still pretty dang big.
She's thick.
She's thick. Very thick.
Yeah.
In terms of orbit and rotation, the sun doesn't really have a year, but it does orbit the center of the Milky Way about every 230 million Earth years, bringing the planets, asteroids, comets, and other objects with it, because, as we'll discuss, it does have gravity and magnetosphere and all of those great things.
Yep.
Our solar system is moving with an average velocity of about 450,000 miles per hour or 720,000 kilometers per hour, which is pretty dang fast also. The sun is located in the Milky Way galaxy in a spiral arm called the Orion Spur, and that extends outward from the Sagittarius arm. Shout out to all Sagittarians, me included. The sun rotates on its axis as it revolves around the galaxy, and its spin has a tilt of about 7.25 degrees with respect to the plane of the planet's orbit. And since the sun is not solid, which is difficult, different parts rotate at different rates, hence the day length from the equator to the poles being different.
Interesting.
Yeah, and horrifying.
Yeah.
Structure-wise, it's a huge ball of hydrogen and helium held together by its own gravity, so that's comforting. And the hottest part of the sun is its core, where temperatures can top up to 27 million degrees Fahrenheit or 15 million degrees Celsius. So that'll fry your cookies pretty well.
I would say.
Yeah. The part of the sun we call its surface, the photosphere, is relatively cool at 10,000 degrees Fahrenheit or 5,500 degrees Celsius, if you can call that cool.
I would say, very, very a brisk,
mild at most.
Brisk temperature. Yeah.
And one of the sun's biggest mysteries, the sun's outer atmosphere, the corona, which is kind of funny. It gets hotter the farther it stretches from the surface, and the corona can reach up to 3.5 million degrees Fahrenheit or 2 million degrees Celsius, which is significantly hotter than the photosphere.
No way.
I know. Like, what? Is that even allowed? Or is this allowed? What are the rules?
Mm-hmm. Well, I mean, that's why our planet is warmed.
It's very true.
Because that's how hot it is. Like, you have to be that hot to warm something that's that far away.
Are you calling the sun hot right now, Blair? Are you like coming onto the sun right now?
She is thick and she is hot.
I love it so much. Once material leaves the corona at supersonic speeds, it becomes the solar wind, which forms a huge magnetic bubble around the sun called the heliosphere. The heliosphere extends beyond the orbit of the planets in our solar system, thus Earth exists inside the sun's atmosphere, which is outside the heliosphere is interstellar space. So just outside of that is interstellar world. We're just inside. Isn't that great?
What?
Okay, I will
say it again.
Let me go back.
Say it again.
So material leaving the corona, supersonic speeds being pushed out creates giant magnetic bubble. Heliosphere is what that is. The heliosphere is so large that it extends beyond all of our planet orbits. So we are actually contained inside the sun's heliosphere. Outside of that is considered interstellar space.
Oh.
We're in the bubble.
Yeah. I got it. That makes a lot more sense now. Like, now that I've seen Interstellar, that makes Interstellar make more sense.
It's outside the heliosphere. So
yeah, I got it now. No, that's good. All right.
The core is the hottest part of the sun. Nuclear reactions here, where hydrogen is fused to form helium, power the sun's heat and light, and the temperatures top around that 27 million degrees Fahrenheit, and it's about 86,000 miles thick, or 138,000 miles, or kilometers, I'm sorry. So it is very thick. The density of the sun's core is about 150 grams per cubic centimeter, and that is 8 times the density of gold and 13 times the density of lead. So thick, hot, and dense. I don't know how I feel about the last one.
So is she is the sun, assuming she goes by the female gender, like, so it's made of gas, right?
Yes. Hydrogen
so
and
it's
helium.
Just the density. Yeah, so the density of that gas at that heat makes it thick.
Specifically at the core. Yes.
Okay. All right.
Yeah. This, in this case, we're just talking about the core density.
Got it. Okay.
Yeah.
It just seems like a lot.
It is a lot.
Like, if we could, so my question or my thought is like, if we could build something that could withstand the heat of the sun, which we have yet to be able to do.
Right.
Would we be able to fly something through it? And the answer seems like no.
I mean, I don't know. Wait till we get to the atmosphere.
Okay. All right.
And then you might have your question answered, I think.
Yes, I'll be right here. I'm jumping the gun.
It's fine.
Okay.
There's a lot to unpack, to be fair.
Truly.
So energy from the core is carried outward by radiation, and this radiation bounces around the radiative zone, taking about 170,000 years to get from the core to the top of the convection zone. So they got all these different zones happening. And moving outward in the convection zone, the temperature drops below 3.5 million degrees Fahrenheit. And here, large bubbles of hot plasma, which is ionized atom soup, move upward toward the photosphere, which is the layer we think of as the sun's surface, the photosphere being that.
Nice.
Yeah.
Okay.
So now let's talk about the atmosphere. Above the photosphere is the chromosphere, which is the transition zone, and the corona. Not all scientists refer to the transition zone as its own region. It is simply the thin layer where the chromosphere rapidly heats and then becomes the corona. So it literally is just transferring energy, heat, whatever. And the photosphere, chromosphere, and corona are all part of the sun's atmosphere. So they're just the different layers. And the corona is sometimes casually referred to as the sun's atmosphere, but it's actually the sun's upper atmosphere. So it is a separate layer entirely. And the sun's atmosphere is where we see features such as sunspots, coronal holes, and solar flares. So probably not to your question, because all of those things are spitting out plasma and radiation the whole time.
Yeah. Okay.
Yeah. The magnetosphere, which it obviously has to have one because it's the only thing holding us all together in this system of extreme velocity and speed.
Correct.
The sun generates magnetic fields that extend out into space to form the interplanetary magnetic field, which is also a mouthful, and the magnetic field that pervades our solar system. The field is carried through the solar system by solar wind, which is a stream of electrically charged gas blowing outside the sun in all directions. And the vast bubble of space, dominated by the sun's magnetic field, is called the heliosphere. So, revisiting that word.
Nice.
Yeah, fun. Since the sun rotates, the magnetic field spins out into a large rotating spiral known as the Parker spiral. And this takes the shape of something kind of like a rotating garden sprinkler. Have you ever seen one of those? Pretty common.
I have, yes.
Yeah, thank God. Just take that and multiply it by like thousands, and that's what this looks like on a large scale.
Great. Yeah, sure.
Moons, since it's a star, it doesn't technically have its own personal moon, I guess, but it is dragging the rest of us with it. So
I was like, aren't we moons? We're the moons.
I guess, yeah, that's kind of what they're saying. So we are said moons, and then I guess it could also adopt our moons. You know what I mean? So, moon. It's just like its own version.
Yeah. Or so like we are the sun's moons, and then our moon is like the sun's grand moon.
Sure. Yeah.
Yeah.
Yeah. Yeah.
Or like sub moon.
Sub moon. I kind of like grand moons.
I think so too. Like grandkids, but grand moon.
How's Jupiter's grand moon doing?
Yeah, exactly.
And you'll be surprised to note that there are kind of rings around the sun. This is very fun. So the sun would have been surrounded by a disk of gas and dust early in its history when the solar system was first forming. And some of that dust is still around even today in several dust rings that encircle the sun. They trace the orbits of planets whose gravity tugs dust into place around the sun. So somebody did put a ring on it. And that's kind of stinking
if
cute.
You like it, then you should have put a ring on it.
Immediately copyright strikes. It's true though. The sun has rings, which I don't think is advertised a whole lot, if I'm being honest.
I don't think it is either, and the depictions, I have been very misled by that. So that's interesting.
Yeah.
I'm just happy to know that the sun does not have a baby face in it like it does on Teletubbies, because that is terrifying.
Wouldn't it be interesting if I just pulled that fact from NASA? Funnily enough.
The Teletubbies had it correct.
They were absolutely right. So all of that is to say, the sun's got a lot going on, but this isn't even the half of it. I mean, it is technically the halfway point, but the next half is genuinely where I started to panic.
Oh, good. Okay, well, let's go on an ad break first, and then we can ensue panic.
Perfect.
Hello. This podcast is sponsored by the Tooth Fairy, Santa, the Easter Bunny, Dracula, the Keebler Elves, Jack Frost, Bugs Bunny, Winnie the Pooh, Bigfoot, and the Loch Ness Monster.
Thank you for your continued support. If you are interested in sponsoring mediocre content, please contact us by owl or seance. No, but really though, you can contact us at mediocrecontentpodcast@gmail.com, on Twitter at mediocresquawks, or Instagram at mediocrecontentpodcast. Also, if you like these fake ads, or if you're sick of them and want real ads, rate us 5 stars wherever you listen to podcasts.
Now back to the show.
Welcome back. I would again like to preface that this is where things get real. So hold on to everything you got. Don't panic. And we'll get through this together.
Deep breathing.
Yes, lots of deep breathing. We'll start easy with the potential for life. The answer is no, absolutely not. However,
sun... I mean, who thought that was going to be a yes?
I don't even know why it's an option, but I think it's more to say, like, while the sun itself obviously could not, and it's not even just temperature, right? It's radiation. It's not just 1000%. Like, obviously temperature has a lot to do with it, but
yeah, even if we didn't get burned up, we'd have cancer like yesterday.
Yeah, like on site.
Yikes. Imagine like a superhero's power to like, if their superpower was like to give people cancer.
That would be so sad.
That would be so sad.
What the heck? That's the sun in a nutshell.
What was I gonna say? I'll think of it in a minute. Go ahead. Okay. Continue. I know what it was.
That was so fast.
I know. I'm so good at this. So the potential for life, I feel like NASA including that, or did you include that?
Oh no, NASA included it.
No, so NASA thinks we're dumb. That's what it is. They feel
potential for life. No.
Like, in what world? Not this one. That's for sure.
There's just some people at the bar going, yeah, man, I really feel like we just haven't explored the sun as an option yet.
Right. No, exactly. Anyway, go ahead.
The thing is, right, obviously, no, not physically on the sun, but the only reason that we're able to live on Earth is because of the sun. So there's that. And the water, of course, which we always talk about. There's no water on the sun.
Right.
I would just like to be very clear. Formation, we have discussed this. So it was formed about 4.6 billion years ago in a giant spinning cloud of gas and dust called the solar nebula. And as the nebula collapsed under its own gravity, it began to spin faster and flatten into a disk. Most of the nebula's material was pulled toward the center to form our sun, which accounts for about 99.8% of our solar system's total mass. Much of the remaining material formed the planets and other objects that now orbit the sun. The rest of the leftover gas and dust was blown away by the young sun's early solar wind. So we were like, all right, the rest can leave. Like all stars, our sun will eventually run out of energy. Don't panic. When it starts to die, the sun will expand into a red giant star, which we'll talk about, becoming so large that will completely engulf Mercury and Venus, potentially also Earth as well. And scientists predict the sun is a little less than halfway through its lifetime and will last another 5 billion years or so before becoming a white dwarf, which we'll also talk about. Don't panic.
Not panicking. Very calm. Everyone take a deep cleansing breath. Very nice. Good job.
That's a lot. Exploration. So we obviously know quite a bit about the sun, despite not being able to physically land there because it doesn't even have a surface, even if we could. But NASA and other international space agencies monitor the sun 24/7. So that's why I'm also telling you not to panic. We always have eyes on it, quite literally. But don't actually do that because you'll damage your eyes and you'll never be able to see again. Never stare directly at the sun.
Don't be like someone else we know that stares at the sun.
Don't do it.
Who recently had to take a mugshot. That's all I'm saying. Anyway, continue.
Don't do it. With a fleet of solar observatories studying everything from the sun's atmosphere to its, quote, surface, which we know isn't really a surface. NASA's Parker Solar Probe is studying our star from closer than any other spacecraft. And on December 14th, 2021, NASA announced that Parker had flown through the sun's upper atmosphere, the corona. So Blair, there's your question answered also.
Corona.
And sampled particles and magnetic fields there. This marked the first time in history that a spacecraft had, quote, touched the sun. Again, this is all relative because it's not really a surface. But the Parker Solar Probe is designed to swoop within about 4 million miles or 6.5 million kilometers of the sun's surface to trace the flow of energy, which is studying the heating of the solar corona to explore what accelerates the solar wind. And we'll get into why that's important as well in our solar events section.
Oh, good.
Yeah, made sure to put that there. Solar Orbiter, which launched in February 9, 2020, is a joint mission between ESA, the European Space Agency, and our NASA to collect data that will help answer a central question of heliophysics. How does the sun create and control the constantly changing space environment throughout the solar system? Which is a pretty dang big question, if I had to say.
I agree.
There are other active spacecraft monitoring the sun, including SOHO, ACE, IRIS, WIND, HENODE, the Solar Dynamics Observatory, and STEREO. Those are all acronyms. Don't ask me what they mean. Do your own research. It's a lot. Solar events is probably what made me panic the most, if I'm being honest, because these do impact our everyday life and have, and you'll see in these examples how exactly.
Yes. And so you remember I watched that Bill Nye the Science Guy series on Peacock for those who want to watch it. So like the whole point of that show, just to go on a side tangent for a second, was to show us like how our environmental impact could impact the end of the world, quote unquote.
Sure.
And then how we can like counteract that and fix it in time so that we are not set on a path. And honestly, the only one that we don't have control over is like a solar flare of some kind. So just, but like it's
okay.
So it's okay. And that's what makes it creepy. But anyway, go ahead.
No, you're right. The sun doesn't behave the same way all the time either, which is why we're studying it so closely. Outside of its impact, we also don't have tons of pattern to go off of because it can be rather inconsistent and surprising. It goes through phases of high and low activity, which make up what's called its solar cycle. And approximately every 11 years, the sun's geographic poles change their magnetic polarity, which is not uncommon. So they swap. Earth does this as well. And in fact, we've talked about this before and how eventually your compass will point south or be completely confused and intermediary. But again, don't panic. It's like millions of years from now. But during this cycle, the sun's photosphere, chromosphere, and corona change from quiet and calm to violently active. And the height of the sun's activity cycle, known as the solar maximum, is a time of greatly increased solar storm activity. This means that sunspots, eruptions called solar flares, and coronal mass ejections are common at solar maximum. So it's just like a pushing out of power, energy, and radiation that just impacts, unfortunately, Earth as well.
Yeah.
So solar activity can release huge amounts of this energy in their particles, some of which impact us here, much like weather on Earth. Conditions in space, or space weather, which isn't, it just is what it is, are always changing with the sun's activity. The space weather can interfere with things like satellites, GPS, and radio communications, and it can also cripple power grids and corrode pipelines that carry oil and gas.
Right. So that would be the major threat to us.
Correct.
Is like there would be no worldly communication. And then there's another potential threat that they talked about in the Bill Nye show, that like the governments might think that it's an attack on them specifically and then start setting off nukes, and it's like a whole thing.
And it's like, meanwhile, the sun's just throwing a temper tantrum.
Correct. Yeah.
The latest solar cycle 25, was actually started in December 2019 when solar minimum occurred. According to the Solar Cycle 25 Prediction Panel, an international group of experts co-sponsored by NASA and NOAA said, and scientists now expect the sun's activity to ramp up toward the next predicted maximum in July 2025. So don't panic.
Okay. Another deep cleansing breath. Everybody breathe in, through your nose and out through your mouth.
Don't panic.
We're not panicking.
On a side note, honestly, there's nothing we can do about it. Like, legitimately, there's no need to panic because there's no telling how active it's going to be, what it will realistically impact. We have scientists who are studying this. We have eyes on our power grids and our current capabilities, and I'm sure, positive even, that given the threat to our satellites and things of that nature, people are very much aware and trying their best to come up with viable solutions. It doesn't mean we're going to make it. It doesn't mean that, like, everything's going to be solved if we do happen to have a flare that sucks, but just there's no need to panic because there's legitimately nothing we can do. It's like a tornado, you just, nothing you can do.
Sure. Yeah.
Just a solar one.
Deep cleansing breaths, everybody.
Right.
Moving right along.
The strongest geomagnetic storm on record is the Carrington Event, which was named for British astronomer Richard Carrington, who observed the September 1, 1859 solar flare that triggered the event, the Carrington Event. Telegraph systems worldwide went haywire. Spark discharges shocked telegraph operators and set the telegraph paper on fire. And just before dawn the next day, skies all over Earth erupted in red, green, and purple auroras, the result of energy and particles from the sun interacting with our atmosphere. And reportedly, the auroras were so brilliant that newspaper could be read as easily as in daylight, which is interesting.
Yeah.
The auroras, or northern lights, were visible as far south as Cuba, the Bahamas, Jamaica, El Salvador, and Hawaii.
Wow.
So all the way to the equator area.
Yeah.
That's intense.
Wild. Yeah.
There was another solar flare on March 13, 1989. So again, like, it's not like we haven't experienced these. I just want to be very clear. We've lived through multiple of these events and we're okay. But March 13, 1989 caused geomagnetic storms that disrupted electric power transmission from the Hydro-Quebec generating station in Canada, plunging 6 million people into darkness for just 9 hours. 9 hours, not even a whole day. The 1989 flare also caused power surges that melted power transformers, specifically in New Jersey, they've highlighted. So I don't know why specifically there, but New Jersey.
The sun was like, I don't like New Jersey.
They said there's a couple eating in all the diners, and I've not been invited once, and I don't want to be part of that. In December 2005, so even more recently, X-rays from a solar storm disrupted satellite to ground communications and global positioning systems. If you don't know what that means, it's GPS. So that's how you figure out where you're going. Navigation signals for about 10 minutes. So minuscule, small. And NOAA's Space Weather Prediction Center monitors active regions on the sun and issues watches, warnings, and alerts for these types of events. So you will always know in advance. I'm not saying that there can't be a big one that just completely obliterates things, but I am saying that, like, we've lived through quite a few. They have done some damage, but nothing that we haven't been able to recover from effectively. So again, big breaths.
Deep cleansing breaths.
However,
okay.
This is where things start to get weird for me, because this is kind of like a prediction method, right? So there's a section that I've included called types of stars, and they are genuinely types of stars. However, in my opinion, after reading through this, it's more like phases of stars, because allegedly, even though they're compartmentalized, like, oh, this is a red one, or oh, this is a white one, or whatever, they're actually just phases of a star that it goes through its life cycle. So it just means, yeah, so like some of them might be classified as a red giant, but it's actually a phase, and that phase is red giant star. It will eventually transition to something else as a different star. So let's clarify. Scientists call a star that is fusing hydrogen to helium in its core a main sequence star. And that's what we're talking about. These stars make up around 90% of the universe's stellar population, and our sun is considered a main sequence star. The red giant star, when a main sequence star less than 8 times the sun's mass runs out of hydrogen in its core, it begins to collapse because the energy produced by fusion is the only force fighting gravity's tendency to pull matter together. But squeezing the core also decreases its temperature and pressure, so much so that its helium begins to fuse into carbon, releasing energy. Hydrogen fusion begins, moving into the star's outer layers, causing it to expand. The result is a red giant, which would appear more orange than red. Eventually, this red giant becomes unstable, begins pulsating, periodically expanding and ejecting some of its atmosphere, and will eventually, all of its outer layers will begin to blow away, creating an expanding cloud of dust and gas called planetary nebula. The sun will become a red star in about 5 billion years. So this is what we were talking about as something like collapses in on itself. It begins to expand out, and it was like, oh, it'll take over Mercury, Venus, and maybe Earth also. This is part of that process. So it'll transit.
And Earth, if it doesn't take up Earth, Earth will become very warm.
Maybe too warm, in fact.
Yeah.
So even if it doesn't swallow us,
5 billion years is a lot of time.
It is a lot of time. And also, not to add additional whatever, but technically, depending on where you are in space and like how far you're looking, you may also be looking at the past or the future, depending on what view you're looking at. So like it's 5 billion years in the future for us here on Earth. But I don't know what that's going to look like. Are you going to, like, how fast is the sun going to look like it's approaching you or expanding? And how quickly are you going to start to see changes happening? It's not like one day the sun is its current, like, distance, and then the next day it's on top of your house. You know what I'm saying?
Like, I do know what you're saying.
It's hard.
I don't like it. But you get it. You're not wrong, because technically we're looking at the sun in the past.
Correct.
Because of the travel time of light to Earth.
Right.
Yeah.
So like it's like, what did we say is 8 minutes for so you're looking at the sun 8 minutes ago,
which honestly is not a significant amount of time. It'd be really different if it was like 50 years.
Right. That's what I mean. Right.
So I think 5 billion years on Earth is probably like 5 billion years minus 8 minutes.
Right. Yeah.
Right.
Something like that.
Sure.
I don't know.
Something like that. Yeah.
Okay. So the sun will eventually become that. White dwarf stars. So this is after red giant in terms of phases. After a red giant has shed all of its atmosphere, only the core will remain. Scientists call this kind of stellar remnant a white dwarf, and it is usually Earth-sized, but hundreds of thousands of times more massive. A teaspoon of its material would weigh more than a pickup truck. So we're talking about density here. We're talking about...
We are.
Yeah. So a white dwarf produces no new heat of its own, so it's just gradually cooling over billions of years, because remember, we ejected all of that. And now we have nothing to hold it in because it's all been ejected. And despite the name, white dwarfs can emit visible light that ranges from blue, white to red. So it's just the visible spectrum of light. And scientists sometimes find that white dwarfs are surrounded by dusty disks of material, debris, and even planets, which is left over from the original star's red planet phase. Because again, we're blowing everything up, essentially.
Red giant phase.
Correct.
Yeah.
It's just a phase, Mom.
You said red planet, so I didn't want anyone to get confused.
Planet.
That's all. Yeah, exactly.
In about 10 billion years after its time as a red giant, the sun will then become a white dwarf. So this is 10 billion years in the making. 10
billion.
Yeah, 10 billion.
Yeah.
That's insane.
It is. Okay, go ahead. Sorry.
Neutron stars. So neutron stars are stellar remnants that pack more mass than the sun into a sphere about as wide as New York City's Manhattan Island as long. A neutron star forms when a main sequence star with between about 8 and 20 times the sun's mass runs out of hydrogen in its core completely. So hydrogen said, I'm out. Heavier stars produce stellar mass black holes instead, which is fun. And the star starts fusing helium to carbon like lower mass stars. But then when the core runs out of helium, it begins to shrink, heat up, and begins converting carbon to neon, which releases energy. This process continues as the star converts neon to oxygen, oxygen to silicon, and finally silicon to iron. These processes produce energy that keep the core from collapsing. However, each new fuel buys it less and less time. And by the time silicon fuses to iron, the star just runs out of fuel in a matter of days. The next step would be fusing iron into something heavier, but doing so requires energy instead of releasing it, which it no longer has. The core then completely collapses and rebounds back to its original size, creating a shock wave that travels through the star's outer layer. The result is a huge explosion, or as you might know it, a supernova, and the remnant core is a super dense neutron star. Pulsars, these are a type of rapidly rotating neutron star. They are bright X-ray hotspots forming on the surface of these objects, and as they rotate, the spots spin in and out of view like the beams of a lighthouse, some pulsars spinning faster than blender blades, which is also insane. But there's also magnetars. All neutron stars have strong magnetic fields, but a magnetars can be 10 trillion times stronger than a refrigerator magnet and up to 1,000 times stronger than a typical neutron star. So there's a couple different types there. But they're all created through supernova.
Yeah.
And I don't know what factors determine which one it will become, or if they can switch in and out, or any of those details. So do your own research there. I'm not really sure what determines which one it decides to be.
I imagine it just depends on like how much elements the star has at the time of reaction, because it seems like it's just different ratios of like the basic elements. So and that would probably, if I had to guess, that would probably be what determines the course that it takes.
No, you're more than likely right. I agree. So now we're getting to red dwarf. So we had red giant. Now this is red dwarf, so it's different, but it's still considered red. Not to confuse you further. And it's different than red planet because red planet is Mars, and that's not what we're talking about here.
No.
Red dwarfs are the smallest main sequence stars, just a fraction of the sun's size and mass. Excuse me. They're also the coolest. They're cool, but it's like physically cold, and appear more orange in color than red. When a red dwarf produces helium via fusion in its core, the released energy brings material to the star's surface, where it cools and sinks back down, taking along a fresh supply of hydrogen to the core. Because of this constant churning, red dwarfs can steadily burn through their entire supply of hydrogen over trillions of years without changing their internal structure, unlike other stars. So it's just because of the mechanics that are happening within it that it's causing this to happen.
Yeah.
Scientists think some low-mass red dwarfs, those with just a third of the sun's mass, have lifespans longer than the current age of the universe, up to about 14 trillion years. Insane. Red dwarfs are also born in much greater numbers than more massive stars. Because of that, and because they live so long, red dwarfs make up around 75% of the Milky Way galaxy's stellar population. Because they just maintain themselves for so long. It's just a constant churn of energy and atoms moving in and out on its own.
Yeah.
So, kind of self-sustains. And then finally, just to bring, there's a closing to the existential crisis. So there's the last one. And it's called the brown dwarf. However, these aren't even technically stars. They're actually more massive than planets, but not quite as massive as stars. So it's just kind of like this weird intermediary thing. Generally, they have between 13 and 80 times the mass of Jupiter. So that's still large, technically, if you remember Jupiter.
Yes, Jupiter is large.
Very large. They emit almost no visible light, but scientists have seen a few infrared light, which is just different. Some brown dwarfs form the same way as main sequence stars from gas and dust clumps and nebulae, but they never gain enough mass to do fusion on the scale of a main sequence star. Others may form like planets from disks of gas and dust around stars. So it's just, again, it's like that weird in between kind of situation. So as you can see, some of them are phasal, some of them can just be what they are, and other things are just so different that we kind of classify it as a dwarf star, but it's not really, but it kind of, it's confusing, and we're still doing research, like you should. And also, one final note, just don't panic. The sun is huge, and it's got a lot going on, so
if you're like us and your natural inclination is to panic, don't panic.
Don't panic.
If you're like, I don't know why you guys are panicking, this is ridiculous, then continue doing what you're doing.
Or do research and then panic later.
or that.
But literally, this kind of concludes the solar series for now. We'll revisit it later on some other plane, but hopefully everyone has enjoyed going through our solar system and learning about its ins and outs, what we know, what we don't know, and just exploring something back from, elementary science class.
Agreed.
And then some, really.
Yeah, definitely. And don't forget to not space out and rate us 5 stars.
5 dwarf stars.
5 dwarf stars on Spotify or Apple Podcasts or wherever you get your podcasts. You can send us an email with any questions, comments, or episode topic suggestions at mediocrecontentpodcast or concerns at mediocrecontentpodcast@gmail.com. Follow us on Instagram at Mediocre Content Podcast. Also follow us on TikTok at Mediocre Content Podcast. And you can come chat with us anytime mostly on Thursdays at 3 p.m. Pacific Standard Time, 6 p.m. Eastern Standard Time, and 11 p.m. What is it? What is the time zone?
It's BST. Don't ask me what it stands for.
On Thursdays, every other Thursday on Twitch.
Yeah. And I guess we'll see you guys in another galaxy.
We shall.
Cheers.
Cheers.